recording. So we are doing this guy right here by popular request. So it's that parallel right here. So basically, I'm rewriting this, um, like by like bringing it down. Let me redo this thing. So if we wrote it, if we redrew it like this, and then here's my box, and I'm sliding it this way. Um, this new angle where I'm taking it from would be 32 minus the 18. Am I right there? So that's 14. Am I right? Okay, good. And it says parallel to the plane, so that's what we're doing. We want the x component essentially. So x is equal to r cosine theta. But they're saying that it is the parallel force is 2.9. Am I correct? They're saying that this is 2.9, and I'm trying to find out what my W is essentially. Now, I don't know if this is right, so we're going to actually submit this here in a second and make sure I'm doing this right. Calculator, and let's do it. I'll just put it in right here if that's okay. Oh, actually, it's not okay. That's not the answer. Uh-huh. So I'd have to change it. Bad Chad. A couple times. Yeah, I think I'd say radian most of the time. 2.9887. So I want to do this and submit it. I want to see if this is what they're wanting. Nearest hundredth would be 2 decimal places, right? So I'm going to submit and just see what happens. We'll come right back to it. This was number 20. And we're right, so that's good. Okay, so when you see the box problem, right, then this is the procedure, I would say. This is how you're going to approach that problem. There you go. So you just basically rotate it downward, subtract it, and you're good. Cool? Is that okay?
Yes, sir. This wasn't the right question, by the way. I got
What? I did all of that for nothing.
I'm sorry, Chad. I'm sorry. I wasted 2 minutes of your time.
Oh, that's right. It was only 2 minutes. What question is it?
I can't remember off the top of my head.
I could scroll through some. Do you want me to scroll through it? Okay, so are we good with that? Hi. Glad you're here. The angles? Like this stuff?
No. Like of the 2 vectors, not the 2 boxes. It was one of the later ones. Like you're given 2 vectors, hit the button.
Angle between them?
I think it might have been that one.
Like this guy?
Like X, Y, and Z instead of.
Oh, right. Yes. This one.
Yes.
Mm-hmm. Yeah, of course. Let's do it. I think that we just have our slopes are the 2 vectors that we're going to use. And so I think that it's going to be just the 1 negative square root of 3. And then we're going to do the square root of 3 and then a negative 1, I believe. And then we're going to check this, okay? So when I dot this, so the formula ultimately is the arc cosine of u dot v, magnitude of u, magnitude of v. So I'm going to dot these guys first. That's a 3. I'm going to dot these guys first, and then that'll be my numerator. So 1 times this is the square root of 3. And then I'm going to say plus the square root of 3. So 2 square root of 3 is my numerator. Are we okay with that so far? Magnitude of u and magnitude of v will be the same thing. When you do all this, I think it's 3 plus 1 is 4. Square root of 4 is 2. So I believe what's going to happen is 1 squared and then square root of 3 squared. So that's square root of 4 is just going to be a 2. And it also goes for this guy. So like filling it all in, I've got arc cosine of 2 square root of 3 over 2 times 2. Essentially. Froop. And I don't even need a calculator for this one. When is my cosine equal to the bigger value? At 30 degrees, which is, again, pi over 6. You got it. So there you go. Cool? Oh, you were reading. We don't have time to read during the final exam. Yeah. I know, right? When
Especially if that BX minus
Yep. Yeah, I don't know what they're talking about.
just
Really, I don't know.
At this point, just run off those numbers and vibes.
Yeah.
This feels like we were writing a paper. You had to try to get to the word count, so you gotta expand it. That probably is what's happening. It's just
Yeah, it feels like linear almost, right? Like proofs. Just yeah, put 3 dots at the end and it's fine. Are you good with that?
Yes, sir.
Okay, cool. Okay, so any other popular requests or am I moving on? Chapter 14 it is then. So let me pull that back up. We're going to go to 14. And just keep on cruising. All right. And again, what's on there is everything from your exam that you just took, a week ago. So you should be fine. But there's a ton of these graphing questions, of course. You're going to have one of them. I can't not have graphing questions, of course. So that's nice for you, isn't it? What can you do about these guys if you really don't know?
Desmos rating.
Oh, okay, cool. If you say so. I'll let y'all. Oh, but that one was a 3-part one. Ooh. Desmos 40. I'll still let y'all figure that out. These are not hard. Wait, for reals? The one I just clicked on? Like the one above that? Well, now it's gone forever. See, the function. Wow, that is a terrible question. But well, okay. We're gonna figure this out together. Notice that the Y is squished. The bigger actually means that it's smaller in the end. Oh, I have to submit it. But yeah, I'm confident that's it right there. It's the Y that's squished. It's very difficult, I know. So draw a picture on your blue book and make sure it's, in order. Or you could just yell at me later.
I'm gonna work on my way backwards on the exam. I'll start like 20.
I hate when that happens. I mean, I won't like count a 0 or nothing, but if you want me angry while grading it, I'm playing.
I moved one question because I thought it was more important to answer everything else than that one question. It bites me in the butt.
Limits are definitely on here, right? Can you use Desmos Scientific even on those? I would recommend it. Plug it in. Even if it doesn't work, you plug in stuff really close. They're going to do the polar ones as well. I don't know if that's like I skip a something or other, but there's a polar version of the limits that also should be with all these guys. Yeah, is this the one that's polar? No. I don't know if I have this one on there. Just yeah, too many words. Yeah, here, this stuff. This is on there for sure. Again, do you want me to do it right quick? Oh, okay. You could do it the traditional way, which is actually following directions. Or you do the Chad method, I suppose. What I'm going to do is the traditional method because I want to do my r cosine theta stuff. So x cubed is r cubed and then cosine cubed. Am I right here? Desmos Scientific will not like this, so let me do this here right quick. Hold on. Correct. Yeah. Minus, and then I'm going to have an r cubed again times cosine times sine squared. And then all of this, I have to go back and do another parentheses here. All of this divided by, and if you notice, isn't it just r squared in the bottom? Now, I think that I can get rid of some of my r's. Like here I have 3 r's, and here I've got 3 r's, but I got 2 in the bottom. So couldn't I do this instead? And then I can get rid of this entirely? Notice that I just got rid of 2 r's in both of those guys. Now, as far as the theta is concerned, I don't think that's a good idea, but the r, I don't like, no. 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 No, we're going to do this traditionally. I don't really care, okay? Traditionally wrong. So, it's fine to do what you're doing there, okay? So x equals 0, y equals 0 doesn't work. Okay, great. So what if I just did and then I did and then let's make one of them negative just because. And what do we got here? Looks like a 0. What if I go back to 0 here? What is that guy? Still 0? Round to 3 decimal places. What do you think? Okay. I'll do it by hand now. So, are y'all okay with me plugging in things like this? You should. You should. But now, if I did it by hand, which is still fine, give me a second here. I had, oh man, give it to me. R cubed, cosine cubed. I should have just wrote it down to begin with. I was just being too silly. Silly is the key word. All divided by r squared, and I said cancel all these guys out. So far, so good. Okay. And then I said, I didn't say anything after that actually. I could factor out my r to the front. Right, you're saying this whole thing, you're putting the limit as r goes to 0. So 0 times whatever is equal to 0. So there you go. We're good. It is totally way overthinking, but this is in line with all the other limit ones, and I would say that is a very simple problem along with all the other ones. Cool? Moving on. Yeah, I would use some Desmos to help you, of course. Good, good. Arctangent doesn't matter, it's just a limit. These guys are on there, but they're grouped with a whole lot of other things because I had to group a lot of stuff. So simple partial fractions. Are y'all okay with taking derivatives?
I don't know what that last exam, Chad.
Really?
I'm joking.
Yeah. Yes. Yes. Do you know what section, chapter, whatever? Uh-huh. I would love to do it. I just have to find it.
Projection where like it's like pro J and then like B off to the side that question.
Okay. Then we'll see it eventually then. I hope so. But yeah, keep that in mind. I definitely want to do it for sure. If you tell me exactly where I'll go, but if you don't know, I don't know either. Okay, we'll find it. Keep it in mind, and I'll be trying to see it too. I don't think I have any of these simply because it took too long. There's 4 boxes versus the other ones are only 2, so I can't group those together. It would be unfair on one of you guys. Does this make sense? So I don't think those are on there just because of the fairness aspect. I do believe that these are here. Again, there's only 2 boxes, and you're only taking the derivative. So it says find the derivative and then plug it in. It's basically like all the other ones. Now, 2 different ways to do with this. You can do it the long way that they do, or you can just plug them all in and just one big derivative. You want me to do it? Yes or no?
Yeah.
Okay. Okay. Did you want me to do this one in particular?
Yes, please.
Cool. Sweet. Love doing it. So -2, and then my x, I've already designated it as cosine of t, and I'm squaring it. And then for my y, again, I'm designating it as my sine of t. So if I'm looking back and forth at this, I feel like I can simplify it even more. Like here, can I be funny for a second? Just y'all are gonna hang out with me for a second, right? Stay with me. What does Ryan 2 say again? Stay. Hear me out. Stay with me now. Stay with me now. Hear me out. Here we go. Okay. So what I did was I split my 10 into 2 and 8. Okay, this is not required. I'm just wanting to show a little bit of subtleness here. Notice that these guys can combine together. If I factor out a -2 to the front, you get -2 times 1. Very good. And so what you've done is reduced this whole thing down a lot. And now they just say find dw dt. Just find a derivative, just prime. Well, then this right here goes to a perfect. And then sine squared, we know that one. The 2 goes in the front. You leave the inside alone. Take the derivative of the inside to get a cosine. So I'm getting negative 16 sine t cosine t. I believe what they want is in terms of, function of t in terms of t. I believe this is it. Like that was it. Yeah. I mean, and of course, make sure you're in radio mode. Yes. Yes. Wow, it's really dark out there. Did y'all hear that we're under tornado watch?
Yeah. It's very thunderstorms.
Okay. We're safe in this building. Generally. Would you rather be at your house or would you rather be here in the building? Wow, is that really that much of a shrug? Oh my gosh. What do you live in, like under a rock?
No, my house is perfectly fine. It's just
Oh.
if a tornado hits a building, the building's gonna be gone no matter what.
Nuh-uh, bro, nuh-uh. The building will be here in rubble form, and we'll be under it.
Oh, you're absolutely right, Chad. There are storm shelters, like I think the bathroom is secure. Storm shelter. There's one on my little map. So
Okay.
a lot of staircases are considered like good shelters as well.
Okay.
I might be thinking just fire.
I can actually. Did you want me to go back to that?
I just need the 16.
Yep. All good. But again, there's multiple ways of doing this problem. I prefer to do it this way because you can always take a derivative. That's what I say. You can always take a derivative. So that makes it easier. It's long sometimes, but it is straightforward. Keep cruising. Let's see what else we got. So yeah, that's fine. Okay, so that's on there for sure. Same thing. I don't know if this one was on there because the ln. You can always take a derivative. I think you can take a derivative of ln. This one I believe is also grouped on there because again, 2 boxes. It's not overwhelming. It's really the same style. Correct. Yep. Yeah, it's not hard stuff. Unless you want me to do it, I can do it. 1 box, 2 boxes, not worried about it. 4 boxes would be bad. That would just be too much work for one problem. So yeah, all this stuff definitely possible. This one's on there, gradient. Go ahead. Yeah. That's after gradient, isn't it?
Yes. Yeah. Like right after.
I don't know if this one specifically is on there. I think I might have gotten rid of arc sine. What's the derivative of arc sine? You can always take a derivative. Nah, I can't remember either. I think I removed that one. Throw something at him. Yes, is this the one you're talking about? Perfect. Let's talk about it. And did one of y'all send me something about this? And I was confused. I can't remember. Anyways, yeah, let's talk about this one. Look at outside. Isn't that crazy looking? And look, you're safe and warm inside. Okay, not warm, but you're safe. You're safe inside. Yeah, it's great. Positive thinking, guys. So the derivative in the direction of this, I thought that there was a different formula for this one.
This one, if I remember correctly, it's rad f. Then you had the line, of course, and then you had the point there, and then it's times u. But if you don't have u and you had a, it would be a over
Magnitude A.
But u already accounts for that.
Right. Well, I'm going to do this because I'm very picky. But this is giving me a not a scalar. I think they wanted a scalar. And so I can't remember what we do with that. Oh no. That's a dot product, so we are getting a scalar. Not bad. Okay, we're good. And I even put a dot there. Okay, so yeah, grad G. Derivative in terms of x. I'll wait. So low D high. And then minus high D low divided by the square of what's below. You got the song down. Comma. And then we do it again. So yeah, low D high minus high D low. Yes. Yeah. Yeah. Gosh, man. Yeah. I want to plug in that point though, because that's ginormous, and so I want to plug in the -1, 1. The calculator, honestly, that's just overwhelming. Let me do this. Okay. Five xy plus 7 squared. Okay, that helps a lot. That's nice. Look how pretty. And then I'm going to alter it slightly. And I got it -10. That helps a whole lot. Are y'all okay plugging that in? Like, I don't have to keep that up, right? Just plug it in. Yep, so we're good there. And then I need to dot that with 3, 4. And what's the magnitude is 5. Very good. Special triangle. I know, right? And so then we got 3 times 8 is 24, and then minus 40 all over 5. That would be 16, -16 over 5. I guess that's it there. Cool. I'm going to do the coffee thing now. Come on, Lee. You're doing it with me, right, bro? We're going to have the jitters together. See, because we got espresso coffee. It's like, yeah. One of my other students gave it to me, and all of my class, all my algebra class, it's like, no, don't do it, don't do it. You're gonna be freaking out. And one person said, you're gonna start talking different languages, and like, it was just really funny. So I had a very little yesterday. I'm just gonna keep pointing at it. Look at all that water outside. It's like pouring off the roof. I'm actually curious to see how flat the sidewalk is. Anyways, are y'all good with this? Yeah. Not too bad. Not too bad. Good? Good. Okay. And yeah, since it's raining, you can't go nowhere. So there you go. Same thing. Same thing. You what? No. You might fail. Wow. Okay, that's good. You said linearization. Did you want this one? Did you want a different one, like harder, easier? Just curiosity. Do we need to expect the error part of no. I hate that. I wasn't sure if I knew you didn't have it on the second example. Oof. Just double check for the final. That and Jacobians, man. Do the simple one. Yeah. I don't need do I need you want the concept? Yeah. So this one's good for you? Yeah. Cool. What makes it complicated is the derivative. So I see. I can take complex derivative. That's not a problem. Sure. So linearization, I believe, is like f naught, which is like you plug in your point, and then you got f sub x times x minus x naught, and then fy y minus y naught. Now that's kind of more technical. We've used different, letters before, but essentially, what I want to do for the 3 comma 2 is I want to plug in 3 comma 2, like right now, plug that in. So I would get 3 squared plus 2 squared plus 1. So that's this guy. And I'm just going to start like kind of filling in the pieces here. 9, 4, that would be 5, 14 basically. So that's like my first component, I guess you can say. When I find my derivative, I'm going to have like a 2x. But this x here is more like x naught, because I'm going to have to plug that in. It's going to have to be a number. And then again, I got the 3. And then for this y, it would be 2, and then y naught, y minus the 2. So again, what is this number right here is a 3. What is this number here? It is a 2. And so technically what I have is 6 x minus 3, and then 4 y minus 2. I think that's it. Use pi as needed. What do you think?
I guess they want us to go to polar form. We have an x squared plus y squared plus dr.
Yeah. That's kind of weird, isn't it? Yeah.
This is one that I got wrong on the exam.
Yeah.
That's the one where I answered one.
I can't remember. Oh yeah. Oh. Okay. Now we could simplify that. It's not a. There's no point to it really. Are you good with the concept?
Yeah.
Okay. Cool. Right. You're good with the derivatives we did, the fx and fy. Okay. I know. I'm just making sure. I mean, not like I'm saying like, are you cool with how I'm plugging it in? It's not x technically. It's like a number. We have to get a scalar on the outside. Yes, I like that. Yeah, that would be way better. So yeah, fx at. Oh, okay. Well, how about like, I don't know, and then just put some more little. No. Yeah. Moving on. We could be silly with our notation once in a while. The storm. Is that why we're? No. Like, why are we spinning here? Okay, there we go. This is on there. This has got its own little pooling, and I'm trying to. I was trying to group them together. I only had like 20 questions. Technically 21 now. 21 questions total to work with, and so I think I had to group these with the Lagrange stuff. I think. But you can see that. I mean, it's a little bit on the complex side. The Lagrange is a little bit on the complex side, so you might get one or the other. And I don't like that, but I had to do something.
I do have one question.
Yeah.
With these specifically, will there be a question where we'll get like multiple different answers, and like the exam two, which just will get one answer for one of each?
No, you could get 2. Yeah, or maybe 3. Did you get 2? Yeah, it's some are 2, maybe 3, but it wouldn't be too many. Yeah, for this one. Do you like this one? Okay, cool. Go ahead.
It's useful for checking and also just kind of getting a picture in case you can plug that into this 3D, and then you get an idea of what.
You know what? Let's try that real quick. I have an idea.
Because I don't think it'll give you the exact points, but at least yeah.
Well, for sure, you can see if it's a min or a max or a saddle. I think that is already pretty helpful. So we'd have to zoom out. We're looking at a minimum, and only one of them. I don't see anything else happening with that. So we're looking at one answer. It's a minimum. I was hoping that I can like click on that point down there, you know? Well, then they need to update. It says it's in beta, so. But yeah, so we already kind of know where we're going with this. That's a good early thing to do. Thank you for that recommendation. Right, it's fx equals 0 and fy is equal to 0. And for this one in particular, I think they're going to be intermixed. So here we go. Oh, we're going to use graphing here in a minute. I'll show you how to do the graphing to get the answer immediately. So 2x, we got a y, and then I've got plus 3 is equal to 0. The other guy would be x plus 2y minus 6 is equal to 0. Stop. There you go. You could do matrix since you're linear. You love that. I'm going to go Desmos graphing. But you're right. It is a matrix, and it will give you the answer for sure. I'm going to do this guy because I'm just a cheater. And it only gives you 2 variables. So that's, yeah. And bloop, we're done. There it is. We're done. But you're right. Matrix. See, you got the concepts. You know what to do. That's awesome. Yeah, if we go back to 3D, you know where it is here. Can you see my axis? And it's like it's right there. Yeah, it's a 2D version. I'm smushing it to the XY plane. Yeah. It is cool. It is cool. Ah. Now they still will want the actual Y value, and so then you go and plug these guys in. Correct. Right. So again, to be as quick as possible and not think, because I want to use all my thinking for like the actual computation stuff. So to prevent thinking, I just plug it in. Maybe. I'll let you try that one. But yeah, because it's in a matrix form, you might be able to find that additional value. Clever. Clever. Okay, cool. I'm a very crude person. All right, good. Oh, the other ones. Oh my gosh. They're going to say, no, you failed because you didn't click no. Oh, so mean, isn't it? Oh, okay. Thank you for that. Yeah, I would sit there for a while like, what is going on here? Yeah.
Question about it. If we were to have multiple points, if we still graphed it the same way, will we find both the points?
Yeah, you would see 2 points on there. Let's try to get one like that.
Yeah.
This. Yes, this one. This one will. I'm pretty sure this one will have it. Let's just check this guy out. I don't have to do the whole thing, but I do want to graph it because there's the XY in there. I think we're gonna have a saddle, but I don't know if that's the only thing we'll have. So yeah, definitely saddle, and only a saddle. Is it literally at 0, 0? Are you serious? It sure looks like it, don't it? Keep moving, keep moving. You didn't see that. Keep moving. Perfect. Okay. Wow, what the hey is going on here? So you can see that right here, you can see that there's this minimum right there, that little spot. But then we also, if you zoomed in, up here somewhere. Nope. Can I, like, not do that? This is in beta, bro. I think there's a saddle down right here. And then we have that minimum that's, like, down there. So we'd have two answers. And then you can do the, well, I mean, looking at the graph, you can tell the 0, 0 will be your saddle, and then anything else is the minimum. But you could do the XX, YY, XY squared kind of thing. Cool? Okay. Keep cruising. Good times, guys. Good times. Wow, this practice quiz is huge. Who did that to you? This is on there. This is on there. I don't know if I grouped them with these guys or not. Maybe, but I did put these in there. So this is, and in particular, this whole like point to a plane. There's a formula for it, but really we're looking at the Pythagorean. Would you want me to do it?
Yes.
Okay. I mean, I don't mind. It was just yes. Yes, do it. Good. Good. Okay. So point to a plane. Let's just draw a quick concept picture here. I got a plane. I got a point. I want to know what that distance would be right here. But rather, I don't need distance. What I want is distance squared, and that's going to make everything easier. A quick version of this is x squared plus y squared plus z squared. Now, what's going on is this is actually the answer that we're going to be working with because origin. This point just so happened to be the origin. And so what I would say is the general formula is this guy. It just so happens that those other ones, because of origin, are 0. Yes? Okay, good. So I'm going to work with that one. That's easier, of course. And what I have is this is to be minimized. So this is kind of like my F. And then my G is the constraint, which you know is on the plane itself. You're setting that equal to 0. So this is what we need, and this is what we need. And then we're going to do Lagrange and have fun with that. Okay. I don't know if this is a required Lagrange problem, but that's just what I'm thinking in my head. Cool? Okay, cool. Since everyone is here, I can't remember who does this. So please, one of y'all remind me, who does their lambda like that? Is that you, Lee? Okay, good. I was looking at these H's like, what is going on? But no, I get it now, though. I got it. That was good. You gave me the eye. You're like, I don't know, man. It still works, though. It works. It was almost more Latin than Greek, and it was good. So, yeah, here we go. So we got grad F is equal to lambda grad G. I'm gonna roll with it, man. I'll probably forget, but anyways. So let's find the derivatives. So this one right here, we're gonna have 2x, 2y, 2z. And now you can see why we have z has a line through it going forward in your math careers. This is not the end for you. You've got so much more to do in math. This is only the beginning. So 2x is equal to 5, that thing. No, I'm playing lambda, but I'm being mean now. I think it's a cool concept, really. Oh, look. Yeah, there is equal to 1 lambda. So looking right here, I'm seeing that lambda is equal to y, essentially. Yes? Okay, so then I can toss that in here, and I've got 2z is equal to y. And then I can toss it up here, and 2x is equal to 5y. Okay. What do I do now?
Couldn't you plug that into the constraint?
Good. Good. Good, good, good. That's right. You plug it in right here and here, then you'll get like a y equals something, and then you're practically done. So 5 times, now that was 2x equals this, so I have to still divide by it, right? So I got 5 halves y, I got a 2y, and then I have again divide by the 2, so then I've got y over 2 minus 10 is equal to 0. Solve for y, which I'm so tempted to go to Desmos. 25 over 2 and one more to be 26. That make a 13 plus 2 is 15. So I got 15y is equal to 10. So y is equal to 2/3. If that's the case, then I can go back and solve for the rest here. And so then x would be equal to 5 halves times 2/3. 5 over 3. And then down here, my z would be 1/2 of 2/3. So 1/3. There's my answers, I think. Concept-wise good? Yes, maybe. Let me think about this for a second. Let me think for a second. I think I can do this. No, I can't do this. So I think the best I can do is this right here is Desmos. But even then, it's going to be just a number, and you can get that by yourself. I don't really like here. I'm tempted to think Desmos or at least a matrix. I know I can do a matrix, but you are unfamiliar with it, and I would not test that on a test. You know what I mean? They're fine, but yeah. Okay. Cool. So yeah, I'd probably just stick to this method. It's probably the best. Let's look around at a couple more just to make sure they're. Oh yeah. So some of these are too easy, and I probably remove them because it is too. It's literally like if you look. Hold on for a second. 3 numbers who add up to 9 and blah blah blah. Okay, there's no distinction between x, y, and z. So 3 numbers, no distinction between them. They all add up to 9. Oh, I don't know. 3 plus 3 plus 3. Okay, great. So like your answer is just 3, 3, and 3. That's not fair to the other person, right? So someone got Lagrange, blah, 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 and you got 3, 3, 3. So I removed those because we would rather have harder problems. Right, Mason? Yeah, exactly. Is that in the same spot?
Oh, is it like on the sphere? Like you're trying to find the furthest point away from?
Oh, this one.
Yeah.
You called it. That one right there? Let's do it. I would love to. Because math is so fun. Right, guys?
Sure.
Yeah. So among all the points here that lie above this plane, find the point furthest from the plane. So I'm saying that it's on this graph and it's not on this plane. Okay, so let's do a little bit of graphing. I basically got an upside down paraboloid, and then I got some kind of plane going on, and I'm saying the point that's furthest away from that plane. So the actual point I'm looking for is on this graph. Therefore, this is my constraint. I would then say, if I'm going to move it all over, I've got x squared plus y squared plus a z minus a 12 equals 0. This is my g. This is my constraint. I'm using this part as my constraint because I know for sure the point's on that graph. That's what it's saying. It's not on the plane. It's on that graph. Hearing me so far on that? Because you have to make a distinction. Which one are we going to pick for g, essentially? We do need an f that will be maximized at this point, I suppose, min or max. And I'm going to go with my d squared just like last time. The problem this time is I will need this. We're not at the origin anymore. But this is definitely incomplete. Definitely incomplete. So I need to find what I can do here. What would be that original point that I can use? Maybe. You're right, because that would give me more. I would go back to my formulas essentially for that. Let me think about this for a second. It's been a while. It's Stump the Professor Day again. And that plane is going to help me. I wonder if it lies above the plane.
Wouldn't the plane be our function in this case?
X and Y. But what I could do is solve for Z and plug it in, but that's not. Give me a second to think about this again. Man, y'all are stumping me, bro. Unless y'all have an idea, I'm willing to hear it out.
I don't know. This seems like a basic sort of problem.
Okay. Okay, how about this? One thing I know for sure is the direction here. To make it furthest from it, should it be a normal vector? Will that be a true statement? Yes? I mean, maybe. Yeah, then we can find a point closer to it. So yeah, you're right. To make it a maximum from this, we've got to follow a trajectory that's on the normal vector. So maybe what we need to do is not this so directly. What? That's what I'm hoping for. But where would I put them? I'm not doing slopes here, am I? On the outside of the parentheses? With the square still? I know what you're saying. You're saying, I'm sorry, it'd be a 1. But then, because we have to have a point there, but that's not it. So you're doing this kind of thing then. Is that what you're saying? I don't know if I agree with that. I'm gonna say no. I mean, it's a concept though. It's a concept. Okay. Well, how about this? I'm stuck on the test. I'm looking at this and I don't know what to do. SKIP, and they come back. And when we do, then we have a little bit more time. So we just skipped it. We went and did all the rest of my tests, and I'm going to come back to it. We have a formula for distance something, right? Let's go look at the distance formula that I wrote down because I was diligent and wrote it down. That was like way back in the day here, wasn't it? No.
Oh, are you talking about 12.5?
Probably. So point to a plane is this guy. Notice they're using the normal vector. Maybe this is the distance that we're wanting to minimize, right? Or maximize in this case. So they're picking just a random other point on that plane. So terminal minus initial, that kind of thing, right? And then my normal vector. Let's use this. So I'm going to say PS dot n over magnitude of n. So in a way, I'm going to rewrite this and say magnitude of PS dot n over magnitude of n. Again, this is just terminal minus initial. What that means is that we're going to use x, y, and z minus some other random point on that plane. And if I plug in a 0, 0, 0, it makes sense, right? So in a way, what I could do, because initial could be a 0, 0, 0, I could just say that that's going to be x, y, and z. Again, that's my answer. That's what we're looking for. Dot n over magnitude of n. So this is my 139 over square root of 1 plus 9 plus 81 magnitude. Okay, let me go back down here with this and simplify it a little bit. Oh, look, so we are multiplying them in a way, just without the squares. And then we have this magnitude-y thing at the bottom. So we got x plus 3y plus 9z just by coincidence. And then we got 91, I think. And I'm supposed to maximize this. This is like my f in a way. I'm going to roll with this. I think this is going to be a good thing. Good so far on that for the concept? So let's now do the math. So grad f, we just do this again. It's like we just keep going in circles a little bit there, but hey, that works. Grad g. So looking back at what, g equals 0, so I have to look at it kind of like this. 2x, 2y, and then a 1. 2x, 2y, and then a 1. So, yes? It would, because it's a multiplier. Thank you. Would you have given me partial credit? Really? Oh, okay, thanks. Would I give you partial credit? You don't know because you didn't? No, I'm just joking. I didn't want to. Never mind. I could say that you didn't need it on this question. So to solve for, actually, it's kind of funny. Do we solve for x or solve for lambda here, 3 over square root 91 is equal to 2y. And then we have 9 over square root of 91. Oh, here we go. Now I could solve for lambda and just plug it back in. Okay, I'm going to go with Lee's lambdas next time. They're a little bit better. So toss this guy in, toss this guy in. My square root 91s will cancel. Y'all are in agreement with that? And then I've got, I guess I could just do this here. So that's 18. X is equal to 1 over 18. Y is equal to 3 over 18. And then my z, I have to plug that back in up here. And then we should be done. So 1 over 18 squared, 3 over 18 squared. Oh, I have to type simplified fractions. So I won't. I want to see if this works, though. I want to submit this one. So I'm pausing for a minute while y'all tell me what you want to tell me. Are you happy with that? Do you want to talk about it? Oh, you want me to check it?
Yeah, I have an idea.
Okay.
Not sure if it will work. I'm really not certain if it will work.
I'm not certain I got it right. So 78, 78, 78. Did they only like the final one? Oh, because I didn't. You got to be kidding me. This whole time, and now they're saying, no, now you need to simplify. That's junk, bro. That's junk. Anyways, that looks legit. It looks legit. So, but it worked. Okay, so now that it worked.
So I'm wondering, you put the two functions together originally.
Okay.
Desmos 3D, find the normal vector of the plane, put that in as a vector, and we'll give you a point.
You can't click on it. That's the thing.
I'm not sure because it's a point of intersection. It's slightly different.
We could try. Are you good with this? Can I get rid of that thing?
I'd send it a copy.
Copy it down. Yeah. Oh, while you're doing that, I'm just gonna do Desmos on the side here. Yeah. So this is beta. So you gotta bear with it. So it was z equals 12 minus x squared minus y squared. And then we had 1x plus 3y plus 9z equals... I didn't even write it down. Oh, 0. And so then... Did they do normal vectors like this? How do we do vectors? Okay. Well, a vector actually needs a place to start from, and so we would have a lot of normal vectors here. 0, 0. Like remove it?
No, just click the yellow. It intersects at 0, 0.
Mm-hmm.
So you can start your vector there.
How do I do a vector?
It's to the alligator points, I believe.
That's what I thought.
But I think before you have to put vector as well. You have to say vector.
Oh, like this?
It's
Parentheses?
you have to have the start point and end point. If you hover over the exclamation mark, sometimes you hover over the exclamation point, it'll tell you what it is. You said it needs 0, 0 points.
Start and an end point.
So 0, 0, 0.
Oh. So maybe like... Oh, so I need to flip them, because it goes start to finish. Yeah. So then, point of intersection, beta. But we can try a quest. But I mean, that's the point, though, that we're trying to find. So, oh look, so it's in quadrant 1.
So I have a dumb little request to
Yeah.
see if it'll work. You see on the purple graph, what if you try doing z minus and then setting it equal maybe like equal 0? It might be no, it's not.
Okay. Well, it's beta.
Maybe it worked like how it does in the regular graphing dimensional.
It's beta. Yeah, but I mean, I get your point. That's the concept for sure. Yes. That's a 9, not an A. I know, right? All right, class dismissed. No. Actually, we are at our time, but we could keep going if you want for a few minutes or not. Yeah.
I don't know if this is proper, but you know how we had the function that equals to 0 and then we had the other one where it has 12 in it? What if we were to make one that the one that's equal to 0, make that our f and then our g be the other function?
I don't think that'll work because we're not on the plane. If you find a point on the plane, then you would have to make like a trajectory from there. That's why I don't think that this particular normal vector is good. See you later. Thank you. I don't think that this normal vector is exactly correct. So, yeah. Yes. So technically, where is this? Yes, it's under that graph. So it could be somewhere else down over here as a start point. Right. Like if you note where it actually is intersecting is like, I don't know, almost 1 and 3 and some. But we got fractions that were way tiny fractions. So what's happening is that vector is probably starting somewhere up here, and then it's like shooting through. So its start point, it can't even be on the XY plane because it has to be XY and then on that new plane. The concept's there though. Okay. Cool. Let's keep moving. Because yeah, concepts are great, but yeah, we don't have time for that. Unfortunately, let's see what else we got here. I think that stuff is maybe on there. I can't remember it as much. Yeah, yeah, that's on there. Yeah, Lagrange. I'm just trying to find if there's. This is on there. Yeah, but that's the same as what we already talked about. No, that's not on there. No, no, because that's too difficult. That's on there. Some of y'all had that one, didn't you? Yeah. Did you flip it? I can't remember if you had 3/4. Yeah, that's what it was. And I'm like, oh man. And then of course that number was messed up because of it. Hmm. Yeah. So yeah, those are on there. We've seen them. We're good. Moving on. Come back. Come back later. Okay, let's just see what else like overview for the other stuff. Like point out what's important to talk about. And we need to talk about 16. We haven't even gotten to there yet. We're still in 15, aren't we? 14 was pretty big though. Okay, this is on there, but it's grouped with like a lot of other stuff that's like simple. And I mean a lot of other stuff. This is that same pool. You can go on forever with this stuff here. That's in the same pool. That one's I think the same thing. I just said volume. That's the same thing, and it's whatever. Look. I mean, look. It's a rectangle. It's really not a big deal. But this is all. This I think is finally. Nope. This is the same thing. But there was a point at which I finally broke off and said that these are different, and I don't think that's it yet. This, I think, is where I said that's different finally. I think. Again, I had to group them. So this is on there. Correct. And I can't remember which of y'all did it. It was funny that oh yeah, I put it into polar and then I just solve it with rectangular. It was so much easier. Yeah, like why are we wasting our time here? I know. So yeah, this is definitely on there for sure. I'm not worried about it though, unless y'all are. I can do whatever you want. Good, good. I can't remember if I kept that one.
It's 2.
Oh, the answer's 2. Okay.
Yeah, the final answer is always 2. That question's always 2.
Oh, glad thing I got rid of it. So yeah, this because it's an application, I probably grouped it with somebody else. But yeah, that's certainly some easy stuff there. Oh yes, yes. This one is grouped. Right. This one's grouped with those pictures, the cheese wedges and stuff. I'm sure that's going to come up here in just a second. I don't remember that one. I don't remember that one.
Yes, we can just type it in.
Oh yeah, you just. Oh yeah. Why am I giving you freebie questions? Gosh, these are.
Square root over pi plus another square root. Some of them in 16 where it's like something square root of the same thing and then plus pi and it's same helium but a different number.
So again, these are not on there. Not because you couldn't do them now, but because I just didn't have the room. So you don't have them on there. Cardioids and all that, you'll have to get in a different class. This one is all in the same grouping with somebody else because again, it's all just simple integration. No worries about that. There, this is grouped in with those other application guys. I know that some of y'all didn't like that, but you have the formula for that one plane question, right? Cheese wedges. Yep, this guy.
Yeah.
It's my favorite question ever.
There's so many steps to solve it properly that it just keeps breaking down.
I understand. I understand. Cheese wedge. Are we okay with cheese wedge? Okay. Did I have that? I don't think I had average value.
Oh, that's easy.
Then yeah, if I do have one of these, it is only X and Y, and I did put them with some other grouping. Yeah, you're just doing triple integral again and again and again. Yeah. Yes, let's do it. Which one are we doing? This one? You want this one? Okay. Oops. No. Yeah, because we have Desmos graphing now, we should be able to do this no problem.
Are we gonna have one with the variable mass?
Yeah.
But with triple integration.
Oh, probably not, simply because I wasn't on the last exam. So, yeah, you're probably free of all that stuff. Right. So then let's not do that one because it's not on there. I mean, this is fine, isn't it? So okay, we got triple integral, and it says first quadrant. So we're gonna go 0 to whatever, essentially. And so for my x's, how about we'll come back later. 0 to something, 0 to something.
Wouldn't this one just be a double integral?
Just being that way. 1. Right, but I can change that to whatever I need, x and y for the stuff there. So we have our z is going to be, we're going from 0 to what? It's the top and the bottom stuff, isn't it? Or is it literally just double integral for sure?
Yeah.
Just double for sure. Okay, fine. Okay. So on the bottom, okay, so we have a parabola. We should graph this stuff, but we have this parabola. It's a sideways parabola, and then we got a line. So I'm thinking this is on the bottom, and that's on the top. Oh, we should definitely graph this. Yeah, I mean, since we're sitting right here in Desmos graphing land, might as well to see what's going on. Okay. So you know what I want to do? Yes, exactly. dx dy would be way more efficient here. So on the bottom would be the parabola, and because I'm doing x, it's technically y squared divided by 2. And on the top is the line, and I'm doing x equals 4 minus y. Now, what y values are we going to? Y values.
2 to -4.
-4 to 2. But now it does say first quadrant, therefore 0 to 2. Yes. And so that's my mass, right? And then I can just start writing all this stuff down. So we got 14, little m is 14 over 3. And I go in and I change this to an x. And so this is my, I suppose. I saw that on one of y'all's blue books, and I'm like, ew, you actually did it correctly? Yeah, probably. So x bar is equal to my divided by m. Yeah, equals number. So yeah, I'm just being a little silly, but this is basically how to do it. So then x minus bar. Okay. Bloop. Are y'all getting the picture here?
Yeah.
So you're right. This makes it so much faster, doesn't it? And I got to say, most of y'all had issues with this problem because of time.
Yeah, well,
Simply-
it's a very finicky problem that if one small mistake it completely just throws off the question. Because
Yeah.
Your answer, I should say.
Yes, exactly.
3 triple integrals they have to do.
Yeah.
Some of them with similar amount that I use.
Yes. Okay. Well, that was not too bad. But so graph it, be sure of what your limits are, and boom, boom, boom. Right? Easy. Easy now. Yep. Super easy. Yeah. Cool beans next to Nito burritos. And awesome sauce. They're all right next to each other in the grocery store. This is one of those graphing things. Yes. But for sure, this is a question on there, and you have to click it correctly or draw it at the very end and don't tell me
partial
about it and
credit.
get partial credit or
Wait
something.
for it.
Yeah. Sheesh. Again, super easy now, right? Let's like just click around. Right, divide by the pi. Yeah. Same stuff there. You're good. Secant, can we handle that? Yes, because it's Desmos graphing now. Hey, look at that. Yeah, I don't worry about any of these now. Okay, same kind of thing, top, bottom. Change it to whatever you want. Are we cool with those? Mm-hmm. Yeah, I forgot. Oh, no. This is not on there. This is the Jacobians. So that's not on there. All right. Well, that was not too bad. So apparently, chapter 15 will go a lot faster. Okay. Cool. No Jacobians. No Jacobians.
Hey, we could always throw it into Desmos and we won't even have to worry about Jacobians.
So, I need to stop because I got a meeting here like now. Are you cool with that?
Yeah.
We'll go over 16 next time. And that's tomorrow. You're going to be here tomorrow?
Yes.
Okay. Thank you, guys.